Hello, Algebra 2. Hope you're doing well today. We're going to take care of POLY2, which is adding, subtracting, and multiplying polynomials. So let's start with the guided notes like we always like to do. We're going to start with some vocabulary this time so we're all on the same page. A lot of this should be reviewed for you, and if it's not, that's okay. But yeah, let's just go ahead and take a look at some of these things. So a polynomial is an expression with one or more terms. Poly meaning many, nomial meaning terms, many terms. If the expression has exactly one term, we call this a monomial. It's mono, single, monomial. If it's got two terms, we use the prefix of bi, binomial, meaning two, binomial. If it's got three terms, tri is our prefix, trinomial, like tricycle, meaning three. We kind of only really name the first three, like 1, 2, and 3. After that, I mean, they've got names, but we don't use them. We just go with the general term of polynomial. So the different parts or pieces are called the terms. If those terms have the same variables and same exponents, we call those something special. We call those like terms. Like terms. Those are things that can be combined using addition and subtraction. If the term has a variable, the number multiplying, so that number directly in front of the variable, is called the coefficient. If that term does not have a variable, we just call that a constant. That's just your normal numbers. So those are our first two things. We got polynomials. We talk about some term stuff. That should be from Algebra 1 and from middle school. And then all polynomial expressions, we like to write these in what's called standard form. Standard form. Meaning that we place the terms in descending order. So the exponents go from the highest exponents to the lowest exponents. So descending order. Now, all of that's all well and good, but until we've applied that, maybe it doesn't make a ton of sense. So let's go ahead and take a look at this. Look at some examples here, some vocabulary stuff here. It says determine whether each polynomial is a monomial, binomial, or trinomial. Well, I'm looking for the things that are added together or subtracted from one another. I can make this also addition. Subtraction is also, it's just addition. So if I do that, I have two terms added together. We call two terms a binomial. You're going to try B and C and then check your work here in a minute. Determine whether each of the following pairs are like terms. Do they have the same variable and exponent? We're going to write yes or no. I'm looking at A, I have 6x squared and just x squared, 1x squared. Do I have the same variable? Yeah, x. Do I have the same exponent? Yeah, squared. These are like terms. You're going to try B, C, and D. Take a look at D. We're going to check that one out here in a minute too. Look at number 3. For each of the following expressions, identify the coefficients, so the numbers multiplying the variables, and the constants, just numbers. We have 7x plus 1. Our variable is x. Our coefficients, the value multiplying x, our coefficient is 7. Our term without a variable is just 1, making that our constant. You're going to try B, C, and D, and then check your work here in a minute. Now, let's talk about standard form again. We're trying to write from the biggest exponent to the smallest exponent. What I have here is negative 2x plus x squared minus 3. My biggest exponent is squared, so I'm going to say put the x squared first, then minus 2x minus 3. Our degree, or what's the biggest exponent we've got, is 2. We call this a second degree equation. Okay. Now go ahead and try numbers or letters B and C, and then pause it. Well, you're gonna have a pause anyway. Come back, take a look, see how well you did. All right, let's go ahead and give your answers a check here. Part C on the first one, number 1C is a trinomial. B was a monomial. 2, we only had one other one that had like terms, which was D, because you got to remember XY is the same as YX because that's multiplication. 3 times 4 is the same as 4 times 3. So you can write it in any order. So even though they look a little bit different, they are like terms. For each of the following expressions, we had coefficients and constants. For B, we didn't have any constants because there's no just plain numbers. And our coefficient to our variables here are -4. For C, there were no variables, so there's no coefficients. Our constant is -9. We have 2 coefficients for D. I hope you picked up on that. We have 2 different variables. We have one variable, but with different exponents. We have 1x squared, so we have coefficient of 1. We have -5x, a coefficient of -5, and our constant is just 4. That's a value without a variable. If you also check out, let's see here, our degrees of polynomials, we have, I'm going to highlight B here. We change this into -7x plus 8. We don't write the 1, but this is like -7x to the first power. We just don't write that, right? But we know that that is a degree of 1, an exponent of 1. All right, so let's go ahead and move right on here. What are we going to do first? Well, we're going to add and subtract some polynomials. You can only add or subtract when you have like terms. When adding or subtracting like terms, you only add and subtract the coefficients. We don't add the exponents. That comes later. That's some multiplication kind of stuff. You can use either a horizontal format or a vertical format. I'm going to show you a couple of each, and then you can pick what you'd like to do. Example here, I'm going to do a horizontal on number 5. It says 4x minus 3 plus 7x plus 8. These are example of adding 2 binomials together. They both have 2 terms. Think about it this way. This is like multiplying 1 out in front, distributing a 1 through. We know how to do the distributive property. If we distribute through, 1 times 4x is 4x. 1 times -3 is -3. So sometimes you'll hear when it's just a +1 outside and you don't see it, you can drop the parentheses. It's not really dropping the parentheses, it's just distributing a 1 through. Same here, distribute the +1 through, plus 7x plus 8. Combine like terms. So I have 2 terms that have x's. I have 11x. I have a -3 and a +8. 11x plus 5. Let's go ahead also and think about how number 6 would be approached. This first one, still being multiplied by a +1, this first binomial, 1 times 3x is 3x. 1 times -4 is -4. That's our first binomial distributed through. But we have subtraction in this next one. This is like a -1. You could actually rewrite this as plus -1 times 2x plus 6. Now, if you don't need to do that, you don't need to do that if you see that already. But if it helps you when you're doing subtraction, go ahead and do that. So if I distribute a -1 or multiply every term by -1, this becomes -2x minus 6. Well, 3x minus 2x is 1x. We don't write the 1, we just write x. -4 minus 6 is -10. That is how we do subtraction. That's our horizontal way. That's how I like to do it sometimes. And you're going to try some of these bigger ones down here and then check your work. But I want to highlight out here. Number 12. This is more of a vertical format. What you'll see is they've lined up the terms that have x cubed, x squareds, just the x's, and the constants. They've lined them up in a vertical fashion. Now we're doing subtraction though, right? So let's look at this first term, -2x cubed minus -2x cubed. You know right away, minus a negative is plus a positive. You've told me that 1,000 times from Mrs. Hunt, right? Minus a negative is plus a positive. This is like -2x cubed minus negative or plus 2x cubed. Well, -2x cubed plus 2x cubed is just 0. 5x squared minus 3, oh, this is a squared, by the way. 5x squared minus 3x squared, This is 2x squared. Over here, negative x minus, well, there's nothing there. Well, nothing there means this, I mean, we don't have to write a 0, but it just indicates that there is a 0. Negative x minus 0 is just negative x. 8 minus negative 4, minus a negative is plus a positive, plus 12. This turns out to be 2x squared minus x plus 12. Now, how I would love to see you do this, and if you want to do this, I would highly suggest it, unless you see it the other way, is turn the addition into subtraction. The top term would still be, top polynomial would still be negative 2x cubed plus 5x squared minus x plus 8. But I would essentially distribute through that negative sign and turn this into addition. So instead of minus negative plus 2x cubed, it'd be minus 3x squared plus 0 plus 4. We just turned we just turned subtraction into addition. Figure out which way works best for you. Go ahead, check your answers in just a minute. All right, take a quick moment to check your answers. You can pause if you need to, because we're going to go on to multiplying polynomials. So let's go ahead and multiply some polynomials. Let's do this thing. Get to the top here. To multiply a monomial, or one term, by a polynomial, many terms, you multiply the monomial by each term in the polynomial using the procedure for multiplication of exponents. Think distributive property because it is. In other words, we're going to distribute the negative 2x to the 3x squared, to the negative 4x, and to the positive 5. Well, negative 2 times 3 is negative 6. X times x squared is x cubed. Negative 2 times negative 4 is a positive 8. X times x is x squared. 5 times negative 2 is negative 10 times x, because we just have one x to multiply, and we've distributed through. It's the distributive property when we're doing a monomial. It's actually going to be a distributive property no matter what we do, but we'll see. We'll see that in a second here. If we take and distribute this one, actually, I'm going to let you guys do these. I'm going to hit pause here, and then you guys are going to check your work here. All right, as you check your work there, as you distribute through that monomial to everything in the polynomial there, the first one ends up being 7x cubed plus 4x. Number 2, we end up with 10x squared plus 14x cubed, but we do need to put that in standard form. So we put that cube term first. We have 14x cubed plus 10x squared. What happens when it's not just multiplying a monomial or a monomial through a polynomial? Well, guess what? It's still distribution. It's still distribution. What I'm going to do is take and multiply the 2x times x squared times negative 2x times positive 1. And then I'm going to take that negative 3, the minus 3 here. I'm going to take and distribute that to the x squared, to the negative 2x, and to the positive 1. So let's see what that looks like. Here's how I like to write this out. I'm going to take my first term in the first polynomial. So 2x times x squared minus 2x plus 1. Give myself a little room over here. Then I'm going to say negative 3 times x squared minus 2x plus 1. I'm going to take and distribute all those things through and then combine like terms. That's why it comes full circle, right? So 2x times x squared is 2x cubed minus 4x squared, because 2x times negative 2x is negative 4x squared, plus 2x, because 2x times 1 is 2x. Again, just distribute through here. I'm going to do the same thing with the negative 3. I'm going to do the same thing with the negative 3. I'm going to take the negative 3, multiply it by x squared to get negative 3x squared. Negative 3 times negative 2x is a positive 6x. And negative 3 times 1 is negative 3. From over here, I just combine my like terms. If I combine my like terms, here's what I ended up with. I've only got one term with cube, so 2x cubed. I've got two terms with squareds, negative 3 and negative 4x squared, so negative 7x squareds. I've got two terms with x's. Those are right here. Let's kind of do it like this. This doesn't always work out this way, but sometimes it does. Plus 8x. My constant is -3. And I have just multiplied two polynomials. Now, let's take a look at binomials down here. When you see a binomial squared, you write it out, then multiply. Here's the biggest mistake that people make, and I've already seen people do it in quadratics. Y plus 6 squared, y plus 6 squared is not, this symbol means is not y squared plus 36. It is not that. Do not do that. Do not do that. Because something squared is itself times itself, right? So y plus 6 squared is y plus 6 times y plus 6. You may know this as FOIL. That's maybe the first outside, inside, last. If you don't know it by FOIL, that's okay too. Use distribution. 4a minus 7 squared, I'm going to give you the little hint, the starter hint here. This is 4a minus 7 times 4a minus 7. I'm going to hit pause, and you're going to check your work when you come back. Remember to use distribution or FOIL if you know how to do binomials. All right, if you have done those out using distribution or FOIL or whatever method you want to use, the first one, number 9, you'll end up with y squared plus 12y plus 36. And on number 10, you do end up with 16a squared minus 56a plus 49. You remember to distribute the 4a to the 4a minus 7 and the -7 to the 4a minus 7. All right. With that said, what I want you guys to do is take a look at the box method. Okay, take a look at the box method. What happens when they do this? When they take the polynomials, or a box or table method, you take your polynomials, you take your first polynomial, and you make columns out of it. So 7x plus 2, you'll have two terms, so you'll have two columns here, 7x and 2. I guess it's kind of a row. But then you take your second one, 5x plus 1. You have two terms. You make that. So it's a 2 by 2. You'll have 4 boxes. You multiply in each of the boxes here. You can see this, 7x times 5x, 7x times 1, 2 times 5x, 2 times 1, and then you combine like terms. You end up with 35x squared plus 17x plus 2. I'll show you how to do that in number 3. I have two terms. I have 7x squared minus 2. On the top, I would have x squared minus 5x minus 1. I'm going to create a box that has 2 rows and 3 columns. 2 rows and 3 columns. So 7x squared times x squared is 7x to the 4th. 7x squared times -5x is -35x cubed. 7x squared times -1 is -7x squared. -2 times x squared is -2x squared. -5x times -2 is a positive 10x. -2 times -1 is a positive 2. From here, we combine like terms, and we've done the exact same thing that we did with distribution. I know it's going to be kind of a lot to write, so I'm going to I might write it above it here. My final 7x to the 4th, there's only one term to the 4th. There's only one term that's cubed, -35x cubed. I got two terms that are squared, a -7 and a -2, so -9x squared. One term with x plus 10x, then plus my constant, which is 2. So what I want you guys to do is, I'd like you to do number 4, in this case, using the box method, and then do number 8, whichever method you want. Then come back and check them when you're done. All right, go ahead and check your work on there. Number 4 ends up being -5x cubed plus 16x squared plus 2x minus 1. And number 8 down there, 10x to the 4th plus 19x cubed plus 3x squared plus x, just 1x, minus 1. So with that said, hope you guys have a great day. Take care. We'll talk to you soon.